WCS. I will name it as sorry, I don't name it, I will move it in U axis. Okay, that is minus LA and minus 3. Okay, this is I can define at the same point. I don't need to move the WCS. I am moving this one because if in future I want to do the parametric studies, it will not move with the slot, because slot is a different thing. It is excitation, the antenna is fixed. So I just yes, am I at the middle? I have to see. No, minus 3 minus WS by 2. Okay, preview. Yes, now I am at the middle. Okay, so note this one, LA minus 3 minus 3 is nothing but the stop extension. Okay, then I will press OK. Then I will define the dielectric resonator. DRA will put in U axis minus LA by 2, tab LA by 2 minus WA by 2, tab WA by 2, and I will give a W maximum as H1 since it is the height of the dielectric resonator. So I will press new material and assign it as DRA, and I will press epsilon 20 and mu I will make it as 1. Okay, so select your color, press OK. So you can see the preview. Yes, we have our dielectric resonator antenna. Okay, then press OK. You can see it or visualize it. Yes, we have dielectric, we have everything. Now the coaxial cable or the connector by which we will feed it. So select this point, assign your WCS with this point, then move your WCS in U axis R0 plus RI, means the outer radius plus the inner radius of your coaxial cable. Means your cable should at least at a particular distance to place it. Okay, so you can also design the cable here and here, but it will just vary the impedance matching, but it can happen. Okay, now press OK. So now I will define the pin. Select cylinder, press escape. Pin for coaxial cable, it is in W axis, outer radius is RI. Then everything I will remain it as it is, and the minimum of the pin is minus H. Okay, and minus T. Okay, so now now I have in our negative W axis minus H minus T, and here I will put 80 multiplied by the height of the substrate. Well, why I am taking such type of height of the SMA connector, because it is approximately is equals to the SMA connector we are using during the practical manufacturing or fabrication of the antenna. So it is approximately that much. I have already calculated the approximate value. Okay. Then I will select copper as the material. I will see the preview. Is it here? Yes, it is here. Just zoom it to see. Yes, I do have a coaxial cable, SMA connector pin. Then I will press OK. Then I will select the top of the pin face, the pin top face. Then I will transfer my WCS to that. Then I will design the substrate of the coaxial cable, or it is having outer radius RO and RI. I have already mentioned these parameters here, RO and RI. Okay. Then I can define the W min. Okay, -8 into the height H. I can see the preview. Yes. Then I will define a material from material library, the practical material used in SMA connector, that is known as Teflon. Just find the Teflon in material library. Yes. Always we have to use the lossy material, because in practical we do not have such material known as loss free. Okay, it is having epsilon 2.1 and all. Okay, so I am loading this. Okay, so I can see the preview, then I can press OK. So we do have fewer parts, so then I will select this one, the face, and then I will extrude this one, will known as coaxial cover, and I will give it a height of T. Okay, then I will press OK. Sorry, I just put the wrong material. It should have a conductor, means it must have to be a copper material. Okay, so I will change the material from here. I will change it to copper. Okay. Yes, now we have a perfect coaxial cable. So now the coaxial cable is done. So as per the previous tutorial, you have to insert it properly, because we have to insert the pins properly. So I have to select first the substrate, then I will click insert, then I will select the pin, press enter. You can see you have a hole inside the substrate and your pin is directly touching the transmission line. Then I will select the ground plane. Okay, ground plane. Then I will put insert, then I will select the pin and enter. Now you can see there is also a hole in the ground plane. Then the ground plane is selected. Again I have to insert the coaxial cable substrate inside the ground plane, and yes, you can see is it inserted? No, I don't think it is inserted or not. Oh, sorry, the ground. Yes, I have to press the ground, then I have to insert the coaxial substrate and I have to press enter. It is showing like this. Why it is not entering? Is there anything wrong? Oh, I have forgotten to I find the error. Actually I have mentioned the coaxial substrate height just we have if you will visualize the structure clearly, I have just in W axis mentioned 8 into H while there should be another T. There is a modification here, please note it. Now press OK. Okay, now I think we are done. Okay, so here I will press ground. Yes, there is already a hole. Okay, I have inserted the ground inside the ground the coaxial cable, and as well as the cover. Okay, so we have everything ready. Okay, so I have already shown you that we are now ready to simulate our antenna. It is ready. So what I will do is I will select the face of that coaxial cable, just zoom it. Yes, I will select this one. I will now select waveguide port. You can go to solve menu, and also you can use this option also. So while I am using the shortcuts, then press OK. We have the excitation port. Okay, now our antenna is ready. I have already defined the frequency range. Boundary condition is okay for the antenna. So now I will just simulate it. Okay, sorry, before going to this, you can put field monitors. So I will give some field monitor. Before giving the field monitor, you should calculate your resonant frequency. So I will put it as 5.78. I will apply for electric field, apply for magnetic field, then I apply for the far field. Okay, now I have already mentioned 3 fields. You can see here: far field, electric field, and H field at a frequency 5.78, which is our resonant frequency. If you will calculate, then you can get it. So I will just click this one, and already it is set. Accuracy you should give it 50, and normalize the impedance of the port. I will start. So you can see the messages here. Okay, so well, I think the simulation is complete. Steady state energy created in mate, and the solver is solved. So you can see the results here. There is no error, and you can see the results here. Yes, it is resonating around 5.7871, and then you can see the port signals is decaying absolutely to 0. Then you can see the energy level decaying to 50. Yes, everything is all right. So from here you can put axis markers, and you can calculate the bandwidth of your antennas. It is approximately 500 megahertz or something around it. Okay, then you can visualize the electric fields. Yes, the electric fields you can visualize here. I will zoom it a little bit. Right click, select the plot properties, and I will select the Z axis, and I will just move the plane. Okay, now it is something like this. Okay, I will scale it a little bit. Yes,